Hello, students. Have you ever wondered why soap doesn't lather as well in some places, especially when the water is from a well or a tap? Well, that's because the water is hard. But what makes water hard? Water is considered hard when it contains high levels of dissolved minerals like calcium and magnesium. These minerals make it difficult for soap to lather, and this is where soft water comes in. Soft water, on the other hand, contains fewer of these minerals, allowing soap to lather freely. Think of rainwater, it's naturally soft because it hasn't had the chance to pick up these minerals yet. Now, let's dive into how we can distinguish between hard and soft water in our experiments. Let's begin with a simple experiment to identify whether a given sample of water is hard or soft. All you need is a beaker, some soap, and the water sample. By rubbing soap inside the water, you can quickly determine the answer. If the soap lathers up easily, then the water is soft. However, if the soap just forms a few bubbles and doesn't produce a good lather, the water is hard. You see, hard water contains calcium and magnesium ions that interfere with the soap's ability to lather. In soft water, these ions are either absent or minimal, allowing the soap to do its job properly. Now, let's move on to another experiment where we'll test for temporary and permanent hardness in water. Temporary hardness can be removed by boiling water, but permanent hardness can't. For this, we take a sample of hard water, boil it, and then filter out the gases. If, after boiling and filtering, the water lathers with soap, it means the hardness was temporary and it's been removed by the boiling process. This happens because the calcium bicarbonate in the water decomposes upon heating, leaving behind calcium carbonate, which doesn't dissolve in water. But if there's no lather after boiling, then the water contains permanent hardness and the minerals are not removed by boiling. Let's now look at an experiment to compare the effectiveness of synthetic detergents with ordinary soap in hard water. When soap is used in hard water, it reacts with the calcium and magnesium ions to form scum, which prevents proper lathering. However, synthetic detergents don't react with these minerals. This means that synthetic detergents work much better in hard water, creating a nice lather and helping with cleaning. So, next time you struggle with soap scum in hard water, you'll know that synthetic detergents are your solution. Now, let's explore the chemistry behind these reactions. When soap interacts with hard water, it reacts with calcium and magnesium salts, forming insoluble compounds called scum. For example, calcium bicarbonate reacts with sodium stearate in soap, and this forms calcium stearate, a solid scum, along with sodium bicarbonate, which is soluble. The reaction looks like this: Ca open bracket HCO3 close bracket 2 reacts with 2NaSt to form Ca open bracket St close bracket 2 to NaHCO3. This is why hard water doesn't lather well with soap. It's because the soap is being wasted in forming scum rather than producing lather. Understanding these reactions helps us see why hard water can be such a challenge in cleaning. To summarize, hard water contains minerals like calcium and magnesium, which make it difficult for soap to lather, while soft water allows soap to lather freely. Temporary hardness can be removed by boiling, while permanent hardness stays in the water. We also saw how synthetic detergents are a much better choice in hard water compared to ordinary soap. So, next time you're dealing with hard water, you'll have a deeper understanding of why it's tricky and what solutions are available. Remember, chemistry is everywhere, even in the water we use every day. See you next time as we dive into more fascinating chemical concepts.